This is an introduction to laboratory assignment 3, named here as laboratory assignment 03, basic electrical measurements and sensing devices. What I would like to do today is to go over some of the basics for this assignment and pretty much point out some of the important topics that are associated with this assignment and give you some guidelines as to how you should actually solve the problems that are associated with this assignment. So I call this Lab 03, Laboratory Assignment 03, or simply Laboratory Assignment 3. So throughout this lecture, I would be using that as the Lab 3. Then there are also other topics that will be covered as I'm going through this. As you've noted with other assignments, the deadline is pretty firm and they're posted on the course website. Usually you have at least 7 days, in most cases more than that, to do the assignment, and this also applies to this particular assignment. There is a course note associated with this assignment. Make sure to refer to the course notes for this assignment. Much of the questions that you may have will be answered by the course notes. If you still have questions, again, these questions should be asked when you read all the course notes, refer to the book, and if you still have questions, I'd be more than happy to help you out. Of course, you can always ask questions. That's not a problem. That's just part of the learning. However, I want to make sure that your questions are what we call an educated question, rather than just asking a question blindly. So please keep that in mind. There are also prerequisites that is associated, that are associated with this course. Again, part of that is the circuit analysis course that you're supposed to have, and much of the information that we go over here today relies on the basics that you have learned from your other courses, your circuit analysis. That's particularly applicable to Lab 3 and also other labs. So you must solve all your problems by hand or type step by step. What does that really mean? By that, I mean you need to go over the problem step by step and solve it step by step. Please do not provide any assignment that I can't read, because if I can't read it, I can't grade it. Some of your assignments, they look like really a circuit, wires everywhere, and there are connectors everywhere. Again, when I read the assignments, you go from top to bottom, left to right. Some students, they pretty much put some information on the right hand side, then they take me back to the left of the page, then they back me to the top of the page, bottom of the page. It's very difficult to follow such an assignment, so make sure that you use as much paper as possible. They're not very expensive nowadays, and you can get 200 pages of a regular paper for like $5. There are also prices cheaper than that. So please, it's okay if you can use as many pages as possible. I know some of you guys are concerned with the memory it takes to scan those papers, but if it's a white paper with white background and you use the reasonable resolution, it's not going to take much space. So keep that in mind. If I can't read it, I really can't grade it, and you don't expect me to grade something that I really can't read. So you must present your work clearly and neatly. I'm not going to subtract any points from you if your work is not neat, but the only problem I have with that is I can't read it. So make sure it's something that I can read. So each and every sheet of the assignment, I'm on item 9 here. I want to discuss that one. You must include the assignment title, student name, course number and title, instructor name and due dates, and all that. Of course, it may sounds really in the electronic era. It may sound really you don't feel like some of you may not feel that you should be able you need to do that, but I think that would help. And also remember that in the electronic era of word processing, it's really not that difficult to put that. Just have a insert like a header or a footer, in most cases header, and just type in your name and that, and you can carry that to every page. You really don't need to retype it. So if you can do that once in the header, it's going to be stay throughout the document. And as always, please do not forget the units. Don't forget them. It is extremely important to use engineering and scientific principles and your critical thinking skills for that course. The way we solve a problem, we start from what's given, and we use the engineering judgment to come up with the formulas that we have, and use them and find the answer. So if you have any questions about this, we can talk about it more. But let me get into the assignment itself. Don't be scared by the part 1 of this assignment. It's really pretty straightforward. There's some information that's given here, and I would actually use them later in solving some of the problems. So let me just skip over them for now. These are the sub bridges that we use in circuits: Wheatstone bridge, balanced and unbalanced. So let me move down and start talking about the lab assignments itself. So you basically have 4 problems for this lab assignment. Some of them there are, of course, more involved than others. In this case, this is a basic meter. Again, it's a primitive, really schematics of a meter, but it would serve the purpose. There are some information given about the meter. Again, you need to refer to the course note or sometimes I may call it handout for this particular lab. It will be pretty much distinguished as, it would be indicated as the electrical measurement and sensing. So it would be, you would won't miss that, and it's going to be posted under the laboratory section of the course. So this particular problem, B, L, and K is given, and you are asked to find the deflection when a direct current of 4 ampere flows through the meter. And then you would find an expression if x sub t, you would find an expression for x sub t if I sub t is 2 cosine t amp. At this stage, this may sound pretty complicated to you, but again, if you read the course notes and watch the lecture that is associated with the course notes, it should be pretty straightforward. In fact, I also there's a solved example in the course notes, and that's pretty straightforward. Again, 2 things you need to do is you need to refer to the course notes, and you also need to pretty much refer to the book and solve problems. There are a lot of work that you guys need to be doing on your own, and of course my lectures would be a complement to the textbook, and the textbook would actually complement my lectures. They go hand in hand. One is not complete without the other, so please try not to skip one and relying on the other, because you would miss much important information that would have been otherwise you won't be able to catch all the information. So for this particular one, again, refer to the course notes, and you should be able to solve that problem. There's also a little lecture that I put for this for problem number 1. Make sure to watch that one as well. So for the second problem, you are to calculate the current. The function for the current is given, and you would calculate the root mean square electric current for the following function. Again, I sub t is t in this case. The bottom line for this particular problem, all you need to do really is to use the formula that's given here. I is I sub rm right here. There we go. All you need to do, the hint is given. All you need to do is really to take one integral from 0 to t. Now, I sub t would be replaced by t, small t in this case, little t, right? And all you need to do is really to take the integral of this function and go from 0 to t, which is 0 to 1, right? So that's really all you need to do. If you're pretty fresh on your calculus, and this is a matter of minutes. If you need more refreshment, then it's going to take you longer to complete this particular problem. So let's move on to the third problem. This is an unbalanced Wheatstone bridge circuit. It has a resistance arm of 440, 602, and 6,000 ohm. They're taken counterclockwise around the bridge. Bridge itself, let me go back to the bridge now. This is a Wheatstone bridge, as you can see, and there would be, we would use this bridge to, for example, in this case, pretty much find an unknown resistance in this case, knowing R1, R2, R3, R sub X down here, that is unknown. In many cases, we are looking for that particular resistance. The there are two switches here. The meter is shown here as G. There is a resistor for the balance bridge that goes across the meter itself. So going back to the problem itself, down here, the bridge, the resistance of the arms are given, and the galvanometer, it's a galvanometer, has a resistance of R sub G. Again, R sub G down here is also given here. This is the R sub G down here, and this is the unbalanced. So keep that in mind. This is not the balanced Wheatstone bridge. This is the unbalanced. Okay, and I just highlighted that for you. So then the meter is the resistance of the meter R sub G is given as 110 ohm, and is connected between the junction of the 40 and 602 ohm resistors down here, and the junction of 400 and 6,000 ohm resistor. Now here you need to be careful when that is being defined. Don't just go by R2, 3, 4, because in this schematics as shown here, it's actually clockwise. Okay, so you need to go counterclockwise. Okay, the opposite. And if you want to take it as counterclockwise, then you need to adjust the R's correctly. I wanted you to determine really when you go to a lab. The first thing you need to determine is how you're going to connect these together. So one of the things you would do is you would actually follow the instructions in this case, which one should be the 400, which one should be the 40, which one should be the 402, 602, and which one should be the 6,000 ohm. In the laboratory, their color, by the color of the resistor, you should be able to tell. But here, it's just given to you, and you need to arrange them properly. It is possible that instead of point, A and C connected, it could be other points here connected. But again, I want you to determine that yourself. So The battery has an EMF of 3 volt. It's shown as E sub B, and negligible internal resistance R sub B is 0, and E is E sub B. Calculate the voltage across the galvanometer and the meter current. So you need to calculate both of that. So how do you do that? So you need to calculate the voltage. So for an unbalanced meter, let me come up here. For an unbalanced meter, so you need to calculate I sub G and E sub G here, right? A little I sub G and a capital E sub G. Okay, so for an unbalanced bridge, as shown, again, you need to, after you set it up correctly, you get R's, the resistors correctly, the arrangement, then you need to use the formula. Really, from that point on, it's the number crunching. And for example, in order to, if you look at this term, this equation up here, okay, this equation, if I can highlight it here now. Okay. In this equation, term R1, R2, R3, and 4 are refers to the resistors in the correct arrangement. In this case, it is clockwise. In the problem that you have is counterclockwise. So don't just plug in the numbers right away. You need to get the correct arrangement, and then as such you can pretty much put R1, R2, R3, and 4 into this equation. In this equation, R1 is known, R2 is known, everything is pretty much known, and then pretty much you can calculate E sub G. E is also given in the problem. So from that point on, knowing E sub G, then you would go ahead and calculate I sub G. Now, I sub G calculation is a little more involved because for I sub G now, there's a term R that you need to calculate. Again, you would go ahead and calculate the effective resistance. It could be R if EF, it's R sub EFF, or it just shown as R. That's really all to it for an unbalanced bridge. And we would use that R. We're going to plug it back into the equation, knowing E sub G and R sub G. Then you would go ahead and calculate that. Okay. Now, in this case, for that particular problem that is given, problem 3 of the lab, what is R sub G? Let me take this equation, let me copy it down here, and let me insert it here, and so I can talk while I'm doing this. Okay. So there you go. So for this particular problem, the R sub G in this case, what is R sub G? So if you really read the problem carefully, you would see that in this problem, R sub B is 0, E is assumed to be as E sub B. So again, you have really what you need. Okay. If you have more questions, again, feel free to read the notes, okay, for this particular lecture, or you can always ask me the question. So knowing R and R sub G, R was the equivalent R that we just discussed a few minutes ago, and in this case, R sub G would be in 110 ohm, and R sub B is 0. That makes our job easier. And really, that's all you need to do. Calculate the voltage across the meter and the meter current. Then we go to the fourth problem, which is the last problem of this lab. And that is, this is using the voltage by either EVM or and voltometer. That's, two way of doing this. There will be error associated with both of those, and in this case, you need to calculate the voltage and also pretty much look at the error. There is a very similar problem in the book that I also solved it in the related lecture for this particular course note that is associated with this lab. So make sure you guys watch that particular lecture. That's really the 4 problems of this assignment and for this laboratory assignment. And I'm sure many of you guys naturally need to review some of your circuit stuff, but you should have enough time to do that, and make sure don't get frustrated. I see some of you guys are really getting frustrated, and try to help, ask for help last minute. It doesn't really help to wait until the last minute. So start earlier, and then discuss it among your classmates on the discussion board. Send the questions for me if you need to, but make sure if you post a question on the questions for the professor portion of the course, and make sure that it is pretty much being addressed to me rather than your classmates. And also, if you want to get a hold of me, you can pretty much use my personal email address. It seems that I have some problems with so I'm going to put it right up here on the this lab assignment, so we should have no problem with that. Okay. All right. So this probably changed the format a little bit, but that's okay. Oh well. Not having enough room here on this page. I don't want to take the instructions to the second page, and well, it is. So why don't I do it up here? There we go. Much easier to do it like that. Right? There we go. Okay. All right, that should do it. That pretty much brings me to the end of the discussions that I wanted to provide you on the third lab assignments. But again, make sure you guys watch the refer to the lecture notes, and also watch the lecture that's associated with that, the lecture note. I'll call that lecture note. I call the lecture itself lecture note number 3. Yeah, for assignment for lab number 3. Thank you very much.